Hi, my name is Erin Glue, and my project is Can Wild Rice Reduce Nitrates? This is my 4th year doing it, so the first year I had to do some research and figure out what some key terms meant. The first one being nitrogen, and that is one of the preliminary plant nutrients that play a major role in achieving the maximum economic yields from production acres. The second one being phosphorus, and that is an essential element for plant and animal growth, and it is necessary to maintain profitable crop and livestock production. I also had to learn some key processes being denitrification, assimilation, eutrophication, and mitigation. Denitrification is the chemical reduction of soil nitrates or nitrites by denitrifying bacteria that leads to the gaseous nitrate loss. Assimilation is the method plants use to absorb organic materials such as sugars and carbohydrates, as well as inorganic materials such as nitrogen from the soil. Eutrophication is the gradual increase in the concentration of phosphorus and nitrogen and other plant nutrients in an aging aquatic ecosystem. And finally, mitigation is a series of techniques used to eliminate risk factors. Next, I had to learn some other key happenings, which one of them being algal blooms, and it's the rapid increase or accumulation in the population of algae in freshwater or marine water systems. Also, I learned what wastewater is. Wastewater is the runoff water from a farm that may have been contaminated by chemicals and fertilizers, pesticides, animal slurry, crop residues, or irrigation water. I also had to learn the difference between point source and non-point source. Point source is a specific place at which pollution flows from, such as a waste management system. Non-point source is a non-specific point from which pollution flows from, such as a group of fields or a group of towns. I also had to learn the difference between in-field management practices, edge-of-field management practices, and land use changes. In-field management practices are practices done within the field to reduce your nutrient loss. Edge-of-field management practices are practices done around the field to reduce your nutrient loss. And land use changes are completely changing the way you use the land to prevent your nutrient loss. For this project, I used a land use change, and I used wild rice in a wetland. And wild rice was once a very predominant species in Iowa, but is currently nearly wiped out. And wetlands can reduce up to 52% of nitrates alone. The Gulf of Mexico hypoxic zone is another key place I had to learn about, and it's roughly 5,800 square miles of dead zone. And wild rice clears nitrogen and pH where it grows, and the most used nitrates in Iowa are anhydrous ammonia, urea, and urea ammonia nitrate solution. My variables for my project are the location where nitrogen is measured. You can see my map down here. The dependent variable is my nitrogen levels, and my control variable is the amount of water I collect and the method of testing. My hypothesis is if water nitrogen levels are measured at the tie line, then the nitrate levels will be higher at the tie line than at the middle of the wetland or at the end of the wetland, right before the water re-enters the stream. My materials are my water source, a container for a water sample, nitrogen test strips, and a notebook and pencil. So my process for this project is I take my retained nitrate strips, as you can see right here, and I go to my water source and I take one of the strips after I collect a sample and I dip it in there, and then I take it and I wait for 30 seconds and I compare it to the bottle to see how much nitrogen for 30 seconds. And then I wait an additional 30 seconds and I see how much nitrogen is for 60 seconds. And then I track that in the notebook, and I can repeat those steps using a new nitrate strip every time at each of the 5 locations. So as you can see from these photos, this is what my wetland looks like. As you can see, this is the rice that we used, and this is what the wetland looks like. And as you can see from this map, we did add a little extra area this year in addition to doubling the amount of rice we use, which is added up to be 100 pounds of rice. So as you can see from my test results, 30 seconds doesn't really show enough data for us to really depend on. However, 60 seconds is what I like to use when we're comparing the data. And as you can see, it's really optimal data this year. We have, of course, a spike right where the nitrogen water from the field is coming off of in that runoff. And then after that, as you get further towards the end, the nitrogen levels do get lower. And that, as you can see, in August we do have a spike, and that is because we did have a spike in precipitation due to it being August and it being wet and rainy, so the water wasn't able to be stagnant and the rice wasn't able to just sit there and soak up the nitrogen. So as you can see from this map, Iowa is right there, and we share about 10 to 17% of the nitrogen going into the Gulf of Mexico. And as you can see, the Gulf of Mexico hypoxic zone is one of the biggest in the world, but also it's not the only in the world. There are big ones in Europe and even along the borders of Lower Canada, and some in the US too. So there are ways to reduce this. In 2013, I put together a task force, and we measured the amount of changes in these 4 ways: inputs, human, land, and water. And that is just seeing how many people are participating, how they're changing the way they're doing it, and how the water is being affected by that. So this is a map of where my pond is relative to the field, so that you can see the field right there, and that is my pond, and that's the field in which the water comes off of down into my pond. And this is the pond wetland that I test in, and you can see that we have about 28 feet of rice, and we did use 100 pounds this year. In conclusion, you can see that the 30-second test didn't gather as much information and data as the 60-second, but the information gathered does show that my hypothesis is correct in stating that the water's nitrogen, whenever it's measured at the tie line, the nitrogen levels will be higher at the tie line than further in the middle or at the end. For future work, I plan to install golden canna lace-leaf frog fruit and Bengal tiger canna hybrid to help reduce nitrates along the shoreline and add a little bit of color. I also plan to install a cost-efficient bioreactor to lessen the nitrates going into the pond. And what got me interested in this project is my 8th grade year, there was the Water Des Moines lawsuit happening, and I wanted to see if I could see how much nitrogen was going into the waters near us. Thank you.